Alrighty, guys. So last week we talked all about functions and reviewed every different type of function. Today, what we're going to review is evaluating piecewise functions. So if you remember, a piecewise function is basically a few different equations acting together as one particular function given different domains. So what do I mean by that? Well, here we have three different equations, right? We have the equation of this line, we have the equation of this line, and we have the equation of this line, right? Now they act together as a single function because they are each given a different domain. So what do I mean by that? Well, if we look at each one, right? This first equation on this left-hand side is only going to be valid for numbers -3 and less, right? Because that arrowhead means this keeps going. Okay, so when we have a number that's less than -3, we're going to be looking to that equation. Whereas this in-between equation is going to be everything in between -3 and -1 on the x values. Okay, so anytime we have one of those, we would have to use this equation. And the last one, right, would be anything greater than the -1, because we see this arrow, we see that it's defined for all of these x values, okay? And that's where we would get our values from for this side of our equation. So if you notice, basically what we have to do is we have to categorize each x value so that we know which equation to use, but they are acting together as one function. So that being said, how do we evaluate f of 2? Well, if we remember, this symbol just means that x is equal to 2. So we need to find the place on the graph where x is equal to 2 and find the corresponding y. So that would be here, and we are defined on this equation right here on our right-hand side. What is it defined as? It has the value of -1. So f of 2 is going to be equal to -1. Okay, so this is very similar to any other type of function, except we have to make sure we're paying close attention to which equation we're using. So what about f of -3? So again, we're looking where x is equal to -3. So if we come on our graph, that's here. But something interesting happens, right? We have two different equations that goes really close to -3. So how do we know which value to take? Well, remember, when we have piecewise functions, this filled-in circle is called a closed circle. That means that it is included, that x value is included in that set, whereas this open circle, or not colored-in circle, means not included, right? So if we were talking about inequality symbols, we'd be talking about or equal to's versus strict inequalities. So looking at this particular example, we were going to skip over this one because this is open, meaning -3 is not defined there. But this part right here is closed, meaning that is the value that is going to satisfy this piecewise function. Now, when we look at this, right, that we have to estimate that's going to be about 2.5. Okay, and that's fine as long as we choose the one that is closed. What about x equal to -7? Okay, now, I mean not -7, I'm sorry, -1. So we take a look, right? We're here at -1 and we go up here to that equation and down there to that equation. But we notice two open circles. So what does that mean? Well, that means my function is not defined here. Not defined. Neither of those y values are going to satisfy this equation, so it is not defined at x equal to -1. Okay, so that's because there are two open circles there. And last but not least, what happens when x is equal to a -4? That's over here. So we go up to our line. We're looking at this point. So that's 2. Okay, so again, it's still like evaluating other functions on a graph. You just have to be careful of those open and closed circles. Now, we won't always have the graph made for us. Sometimes we will be given the algebraic equations, and then have to evaluate from that. So how do we do this algebraically? Well, it's all about identifying which equation to use. So we're always going to be looking here at our domains, okay? This side here is the restricted domains. It tells you what the restriction is for the corresponding equation. So what does this top line mean? Well, for any number x less than or equal to -2, we're going to use this first equation. For any x values between -2 and 3, we're going to be using this equation. And for any values greater than 3, we're going to be using that equation, okay? So it's all about categorizing the numbers. So x equals to -4. Where does that fall? Well, it is definitely less than -2, right? The bigger the negative number, the smaller it's going to be. So that means we're going to plug this x value into that equation. So f of -4 is actually equal to 2 times -4 plus 8, which ends up being 0. So f of -4 is equal to 0. Excellent. And I don't want to block that. What about f of 6? All right, the place where x is equal to 6. Where does that one fall? Well, 6 is going to be clearly greater than 3. We know that. So that means I'm going to be plugging in 6 into this equation right here. So that's 6 plus 3, giving me 9. So this piecewise function evaluated for x equals 6 is equal to 3. Excellent. So what about x equal to -2, right? X equals to -2. Where does that fall? Well, we have a tricky situation here, right? -2 is actually one of those boundary x values that falls on two different parts of my piecewise function. So how do we know which one to plug it into? Well, we have to pay attention to the or equal to. For which part of this piecewise function is -2 a part of the inequality, and that would be this one up here because of that or equal to. So we're plugging in -2 into this equation right here. So f of -2 is equal to 2 times -2 plus 8, which gives me 4. Okay, so last but not least, we have x is equal to 0. Where does that fall? Well, it's not less than a -2, so that's not going to work. It's not greater than 3, so that's not going to work. So we do notice that it falls in between -2 and 3. So that means I'm going to be using that middle equation. So f of 0 gets plugged into this equation, which is plug in 0 for x minus 3. We get a -3. All right. So this domain part right here on our right-hand side is going to be really, really important for evaluating algebraically. Okay, it tells you which equation to use at what time. Okay, so the last thing we have to talk about is graphing a piecewise function. How do we do that? Well, again, we have to pay close attention to these restricted domains. Which one is satisfies which domain? So for -2x plus 1, we have to draw that equation for x is less than 0. So that means I'm going to be drawing that part of the equation everywhere on that side of my graph. Okay, now lucky for us, this is starting at 0, so I could actually still use the y-intercept method of graphing the y-intercept. Okay, deciding if it should be open or closed, and it's going to be open because it's not included. And then because I'm going in this direction, normally I'd be going down 2 over 1 as I continue to my right, but going to my left, I'd go up 2 over 1, up 2 over 1, up 2 over 1, right? And that does actually create a line with a negative slope because we worked backwards for that. So what about the second equation? Well, again, we're starting at 0, so I'm going to draw the y-intercept of -3. It is closed because of the or equal to. And now all I have left to do is count the boxes for 2/3. So that's a slope of 2/3. So that's up 2 over 3, up 2 over 3, up 2 over 3. Connect all of those points.